Now we are going to calculate the bending moments at salient points, and that is our step 5. So if you look at here, this is the free body diagram what we have already obtained, and here we have got forces acting at points A, B, C, D and point E. So these points where the forces are acting, these points are called as salient points. So we shall be calculating bending moments at all these 5 points. There is a sign convention for calculation of bending moment. If your beam is bending in this fashion, then bending moment is taken as positive. And if your beam is going to bend in this way, so it is called as negative bending moment. So this kind of bending, which is positive bending moment, is called as positive curvature, and that is called as sagging of the beam. And this kind of bending, where beam is going to bend in this fashion, it is called as negative curvature or hogging of the beam. So please remember, wherever your beam bends like this, the bending moment is called as positive bending moment, and if your beam bends like this, the bending moment is called as negative bending moment. So we shall start with the calculation of bending moments at salient points. So first of all, I will take point A. So we would like to calculate bending moment at point A. In order to calculate bending moment at point A, we have to consider a plane at particular point A. If you look at here, we have got a sectional plane XX at point A. Now we are going to move from left hand side to right hand side. While proceeding from left hand side to right hand side, if you calculate the moment caused by forces at section XX, you will find that there is no force in the left hand side of this particular section which will create moment at this section XX. So the only force acting over here is force 175, which is acting at the same location where we have taken the section. So the distance of this particular force from this particular point A is going to be 0. So the moment caused by this particular force at point A is going to be 0. So we can directly say that the bending moment caused by this particular force at section XX is going to be 0. So I am writing bending moment as 0 kilonewton meter. So now we would like to calculate bending moment at point B. So to calculate bending moment at point B, the section will be taken at point B. So we have considered a section XX at point B. Now we shall be considering all the forces which are acting the left hand side of this particular section XX, and we shall calculate the moment caused by the forces at point B where we have taken the section XX. Now if you look at here, we have got only force RA 175 kilonewton at left hand side of this particular section XX, which is kept at point B. So bending moment at point B will be caused due to this particular force, which is 175 kilonewton. So due to application of force 175 kilonewton, your beam is going to bend something like this. This is the bending of the beam taking place due to application of force 175 kilonewton. So the moment of this particular force at point B is going to be 175 into distance is 1 meter. So if you compare this curvature of the beam due to bending, it is similar to the first case, which is called as sagging of the beam. So due to this particular force, there is a sagging of the beam taking place. This is going to be the positive bending moment, and the value of the bending moment is going to be 175 times distance is 1 meter. So it is 175 times 1 meter, and that is going to be 175 kilonewton meter. So this is the bending moment at point B. Now we are interested to find bending moment at point C. So to calculate bending moment at point C, the sectional plane XX will be taken at point C. And now we will calculate the moments at point C due to the forces which are acting at the left of this particular section. So we have force 175 kilonewton upward, another force is 100 kilonewton downward. So we will calculate bending moment caused by this particular force at point C, as well as bending moment caused by this particular force at point C. So let's consider first one, that is 175 kilonewton. So when you apply 175 kilonewton, how much bending moment is going to come at point C? So your beam is going to bend something like this when you apply force 175 kilonewton. So this kind of bending will take place. This seems to be sagging of the beam. And due to application of 100 kilonewton, your beam is going to bend something like this. And that seems to be hogging of the beam. So from the shape of the beam, we can easily understand this 175 kilonewton will cause sagging of the beam, while this 100 kilonewton will cause hogging of the beam. So sagging is taken as positive and the hogging is taken as negative. So now the bending moment at point C due to this particular force is going to be 175 kilonewton times the distance is 2 meters. So this is going to be 175 into 2 meter, and the shape is sagging, so it is positive. So it is 175 into 2 meters, that is positive because sagging is taking place. And then second case, due to 100 kilonewton, there is going to be hogging of the beam, so it is going to be negative. And the force is 100 kilonewton and its distance from point C is going to be 1 meter. So minus 100 times 1 meter, and if you simplify the whole value, 175 times 2 is going to be 350 minus 100, so that is going to be 250. So it is 250 kilonewton meters. So we are getting total bending moment at point C is going to be what? 250. So we got bending moment at point C also. So now we would like to find bending moment at point D. To find bending moment at point D, the plane XX is taken at point D. We will calculate the bending moment caused by this force at point D, then this force, that is 100 kilonewton at point D, and then 150 kilonewton at point D. So like that we can find the total bending moment at point D. So now the bending moment caused by 175 kilonewton at D will be 175 times 1, 2 and 3. So 175 times 3 meters, and your beam is going to bend something like this, which is sagging of the beam, so it is positive. It is going to be plus 175 into 3. Now the bending moment caused by 100 kilonewton will be 100 into distance is going to be 2 meters, because the distance of this force from point D is going to be 2 meters. And it causes beam to bend something like this, so it is going to be negative. So since beam is bending in this fashion, the bending moment by 100 kilonewton is going to be negative. So minus 100 into 2. Similarly, bending moment caused by this 150 kilonewton about point D is also going to be negative, because beam is going to bend in this fashion, which is hogging of the beam. So it is minus 150 times 1. The total value we will be getting is 175 into 3 is going to be 525. 100 into 2 is going to be 200 minus 150. So the overall value is going to be plus 175 kilonewton meter. So this way we got the bending moment at point D. Now we would like to calculate the bending moment at point E. So for that we will be shifting this plane XX to the point E. Now here the bending moment at point E caused by this force, that is 175 kilonewton, this force, that is 100 kilonewton, this force 150 kilonewton, and this force, that is 100 kilonewton. So these forces are going to cause bending moment at point E. So we'll calculate first the bending moment caused by force 175 kilonewton. So it is going to be 175 times 4, because the distance of this particular force from point E is 4 meters. So it is 175 times 4, and your beam is bending something like this in this fashion due to this particular force, so it is sagging, so we take it as positive. Similarly, the bending moment caused by this force, that is 100 kilonewton at this point E, is going to be 100 times 3, but it is going to bend the beam something like this, that is in this fashion, so it is hogging, that is negative bending moment, so you will be getting minus 100 into 3. Similarly, bending moment caused by 150 will be negative, because beam is going to bend this fashion, so 150 into 2 minus 150 into 2, and the last we have 100 kilonewton into 1, and again the beam is going to bend the same fashion, that is negative bending moment, so it is minus 100 into 1. So if you calculate this value, this is going to be 700 minus 300 minus again 300 and minus 100. So if you simplify this value is going to be 0 kilonewton meter. At point E we are getting 0 bending moment. Okay. So this way we have calculated the bending moment at point A, at point B, at point C, at point D, and last at point E. So we got all the bending moments at salient points. Now in the step 6 we shall be drawing bending moment diagram. So in the bending moment diagram we have to represent all the values of bending moments at various points of the beam. So we have here the free body diagram of the beam, and we will mark all the points A, B, C, D, E, all the points of the beam by vertical lines, and this horizontal line is called as bending moment axis. So on this particular horizontal axis, we are going to represent the values of bending moment. So this will be called as bending moment diagram. So we have marked all the points A, B, C, D, E on this horizontal axis. So bending moments at the salient points we have already calculated. So we got bending moment at point A as 0 kN, bending moment at point B is 175 kN, bending moment at point C is 250, bending moment at point D is 175, and last bending moment at point E is 0 kN. So we have all these values of bending moments at the respective points of the beam. So we shall be now representing these values of bending moments on these vertical lines. So if you see, bending moment at point A is 0 kN. So I have shown that by this particular dot. So this represents 0 kN. Now at point B, if you see here, we have 175 kN. So this particular point represents 175 kN. So bending moment from A to B has gone from 0, here it was 0. So bending moment from point A to B, it has gone from 0 to 175 kN. Now we will get the bending moment at point C. So the bending moment at point C is 250 kN. So here it is 250 kN. So bending moment from point B to C is gone from 175 to 250 kN. Now we will represent the bending moment at point D. So if you look at here, the bending moment at point D is 175 kN, which is same as this value. So it is 175 kN. So your bending moment has gone from 250 to 175 from point C to point D, something like this. At point E, the bending moment we have calculated as 0 kN. So the value is reduced from 175 to 0. So something like this. So we have got the variation of bending moment starting from A till point E. So it increases from 0 to 175. It goes to the maximum value of 250 kN. From 250 kN, it goes to 175 kN at point D, and then at last till point E, the value of bending moment becomes 0. So this particular variation is called as bending moment diagram, what you have seen. Now since the bending moment is above the horizontal axis, so all the bending moments are positive in this particular case. So like this we have got the variation of bending moments represented by bending moment diagram. So this way you can follow the 6 steps what I have mentioned to draw shear force diagram and bending moment diagram. So this is the free body diagram of the beam, where I have represented all the forces acting on the beam. Now these vertical lines represents the various points on the beam, and now I am going to show you the shear force diagram and the bending moment diagram in a single picture. So this was the shear force diagram we have already drawn. Now on this axis I am going to show you the bending moment diagram. So this represents the bending moment diagram. So the above one, this one is called as shear force diagram, and this one is called as bending moment diagram. So initially we got the values of shear forces, and we have plotted these values of shear forces to get shear force diagram. And then we calculated the bending moments at various points, and we have plotted those bending moments to get bending moment diagrams. So this is how we draw shear force and bending moment diagrams. We shall be seeing some more examples in order to understand the concept of shear force and bending moment diagram clearly. Thank you very much.